It's 1 p.m. in New York, so I think we are now officially ready to start. Welcome everyone back to the beginning of the second half of the first day of SANER, the main conference of SANER. It is my great pleasure to introduce my friends and esteemed colleagues, Neil Ernst and Margaret Ann / Peggy Story. And they're going to be talking about the who, what, and how of SANER research. I'm excited to hear what they have to say, so please take it away.
Great. Thank you, Rick, for the introduction and also for inviting us to present this joint keynote today. So as Rick said, I'm Margaret Ann Story from the University of Victoria.
And I'm Neil Ernst, also a professor at the University of Victoria. Of course, when we said yes to this, we hoped we'd be visiting Hawaii and not presenting online, but Rick, we hope we can ask you for a rain check on that.
Definitely. So today we want to discuss a framework that Neil and I developed that asks about the who, what, how of software engineering research. And we use this framework to help us reflect if our research at the community level is addressing the most important and hardest challenges to solve in software engineering.
We also use the framework to reflect on the rigor, the relevance, and novelty of what we do. This comes at a time in our society where we are also reflecting on how science and engineering is tackling the pandemic that's now impacting everyone on the planet. By researchers working together and building on each other's research, they've been able to address one of the biggest challenges many of us have experienced in our lifetimes. In this keynote, we want to reflect on the research we're doing at SANER and consider how we are together addressing grand challenges in software engineering. As the vision says, SANER has an ambitious scope. It encompasses both software and systems, looks at code and also other artifacts. So one assumes that we would see this reflected in the type of work SANER accepts. So an obvious question is, what is SANER doing in 2021? Peggy, you were the general chair in 2003. What's changed since then?
Actually, not a lot has changed in terms of addressing topics such as software maintenance and evolution, but some things have changed quite a bit. So for example, some of the social channels that we analyze today, such as Stack Overflow and GitHub, those are new. And we also make a lot more use of AI and deep learning techniques that we didn't use back then. But one thing that has remained constant is that some people do question the research that we do at this conference and also at other conferences. So for example, and the people that make these criticisms will remain nameless for now, they talk about, or they ask about the industrial relevance of our research. They ask about, does our research scale or do we focus on toy problems? Are we doing enough in terms of replication? This is also a problem in other areas such as machine learning. They talk about the perils of mining software repositories and the actionability. They question the actionability of our research. And so there is this tension and an aim to balance this tension between relevance, novelty, and rigor that Neil just mentioned as well.
And Lutz Preckelt, a researcher in Berlin, also says that papers that are low relevance, which is broadly defined, are so far from practice that we just shouldn't bother working on them because no one's going to care. Research that has low credibility or rigor, even if it's relevant, is impossible to draw any usable conclusions from. So again, why should we bother with that? What we think is missing from this is perhaps the dimension of novelty, because we might do research that has initial low relevance or initially low credibility, but still has a lot of potential for future innovation in the application.
Right. So in terms of the relevance of the challenges that we address, it's not surprising that at SANER that we focus on the technical aspects of software engineering, such as technical debt, program repair, testing, and continuous deployment, automated documentation. However, many of the challenges that developers experience and report in industry are not so much about the technical issues, but are more about issues to do with working in a distracting environment, poor team culture, and spending time on non-development work.
So given the tension between rigor, novelty, and relevance, and the fact that many of these challenges are indeed socio-technical challenges, how does this relate to SANER's vision for innovative ways of extracting information from software? We think there are three questions that can help address this reflection. Are we tackling the big challenges in software engineering? That's the who question. Are we using the right research approaches? How are we doing our research? And are we building on one another's work? What types of knowledge are we creating?
Right. And so by the end of this talk, we hope to answer these three questions and look at the potential changes that we may make at our community to address some of the bigger challenges we face, such as security, reliability, and ethics in software engineering. However, we don't claim that we have all of the answers, and we conclude our talk with a discussion today around three provocations around potential changes that we could make to our community, and we hope that you will debate these with us.
So the rest of our talk will be as follows. First, we're going to consider who benefits from our research and are we addressing their challenges. Then we consider how we approach and conduct our research. Is it the best way to address those challenges? And then we consider what kinds of knowledge we produce and how we combine that knowledge to address the main challenges of software engineering.
Right. And then finally, as I said already, we're going to conclude our talk today with a discussion and ask if we should change what we're doing and how we should change perhaps our approach for doing research. So let me just start off with talking about the who aspect and answering that who question. So when we think about who our research benefits, we need to consider not just the technical aspects, but also human and social aspects. And if we focus on just one of these aspects, we run the risk of facing what is often called a productivity paradox, where an assumed improvement on one side will not have the overall improvement that we anticipate. So for example, if we pay both attention to both the technical and human side and jointly optimize both of those, then we arrive at very effective tools and interventions that can be designed in our community. For example, CodeFlow is a code review tool that has been extremely successful because of this joint optimization. At a technical level, it leverages static analysis to provide suggestions to code reviewers about issues to raise, but it was also designed with usability and collaboration needs in mind, and as a result, it has been adopted and embraced by its users. Meanwhile, we're at the cusp right now, or perhaps we're already there, of this era of software 2.0 for solving problems that are too complex for developers, for us to write traditional software for. So example, complex human decision problems where we don't even really understand how humans make those decisions. We just have some intuition for it. So in this case, it may be better to use deep learning algorithms to try to find an optimal solution when we have a lot of data for those problems. And this may open up opportunities to broaden who can write software, but it also opens up a lot of challenges, such as how do we write the requirements for it? And then how do we test these programs, as well as challenges to do with security and privacy.
If we look at the set of challenges that SANER tackles, not necessarily solves, but we do a good job on some of these challenges, like the ones that we show here. We probably need a bit more attention on some others, some that build on this notion of a new approach to software creation. Considering who uses and produces software now, perhaps there's opportunity in our research to broaden the challenges we address. For example, looking at sustainable software in the context of the climate crisis, to manage the ethical implications of software, ensure it respects human values, like historically excluded communities, or software comprehension tools that help lower the barrier to entry to new developers. So if those are the grand challenges, the benefit that we seek to add, we should ask whether we're using the right research methods and tools and collecting the right data to address these challenges. So how can we understand whether we have those right tools? The tools would be the research methods and strategies we use, so we can use this framework we show here from our Who, What, How paper to assess it. We developed this part of the framework with inspiration from Runkle and McGraw's influential work in the 70s. On the left, there are the non-empirical, from the perspective of the developer anyway, non-empirical research strategies. For example, if you use a formal theory research strategy, a proof, for example, or you do an SLR that's aimed at researchers, we label those as non-empirical. We don't see a whole lot of those papers at SANER. On the right, there are the 4 types of empirical strategies. Let me drill into those. At the top right, this quadrant refers to research strategies conducted in the field, like a field experiment or a field study where you go into, for example, a workplace and watch developers as they're working. Lab strategies, where we might pull developers into our lab in a research setting, or user studies with students. Respondent strategies include interviews, surveys, focus groups where you ask developers how they feel about something. Where by developer, I mean people working in the area that we're interested in. And then finally, there's data strategies that use sort of retrospective studies of GitHub commits, for example, Stack Overflow questions, and so on. 3 of these quadrants, as you can see with the little blue head, directly involve human stakeholders. We also borrow again from the Runkle and McGraw framework the following sort of research criteria that we aim to maximize or could aim to maximize in our studies. We have realism. So if we go into the field, for example, it's a very realistic setting. Generalizability. So if we use a survey, we may be able to do a statistical inference to the population. And then control. In a lab experiment or a field experiment, you want to control some of the factors that are involved. And finally, in a data study, we have a lot of precision over how we're doing our measurements. So if I look at a paper from SANER, this year's SANER, this is by Bin Hu and his colleagues. This year, they looked at clone harmfulness, which is in a really neat study that uses both a problem description and a solution. First, they use the revision histories to evaluate their harmfulness framework. So that's the first step. Then they use a sort of respondent strategy with a practitioner focus group to see how practitioners reacted to that result. So this choice of methods gives them a lot of precision over how their tool works, as well as the potential for generalizability with the focus group. In another paper this year, Mahmoud Vahidi and his co-authors have created a solution for video summarization called TechTube, which is a great name, by the way, which is then tested against some existing YouTubes for developer knowledge. This is a data strategy that helps them precisely understand the technical properties of the solution, but they then ran a user study with freelance web developers, giving them excellent control over the experimental tasks about that tool.
So we didn't just code 2 papers from the SANER technical track using this framework, using our who, what, how framework. We also attempted to code all of them using the abstracts we had available to us. And here we show the research strategy counts that we determined from all of the 42 papers in the technical track. And of course, we may have this wrong. And so we do invite you to update our Google spreadsheet where we've coded the papers according to these 3 questions. We would hate to misrepresent your papers, but we did our best based on your abstract. And we can see from our diagram that according to our evaluation, that 40 of the 42 papers do in fact report data studies. Well, this is not surprising, right? Given the scope of SANER, because SANER is about using this information that we have at our fingertips to improve software engineering. And we note though, however, that only a handful of the papers report on using other methods, these human methods that Neil talked about, at least from what we could tell in the abstracts, that directly involve humans. And we see that these add up to more than 42. And that's because some of the papers do triangulate, and they triangulate with data studies. I think about 8 of your papers triangulate with other methods, lab, respondent, and field. So why does this matter? Why does it matter if we don't triangulate and we just rely on our data? So we want to use an example from this past year where we've been studying what has probably been the most enormous natural experiment where developers and researchers now find themselves working suddenly from home. And this is pushing a lot of our prior assumptions about the importance of developers being co-located. So not surprisingly, there is a lot of research aiming to understand the impact of this shift to working from home. And if we look at telemetry data, which we can see here on the left from GitHub, the Octoverse report, we can see that it paints quite a rosy picture, in fact. In fact, just looking at this data, we see that commits and code reviews and new projects being created went up right after the pandemic. And so you might think everything is going really well. However, we also did other studies, and there's been quite a few people actually in the community trying to understand the impact of this. And in some of these studies where we question developers through surveys or through interviews, we find out that it's not all that it seems. For many developers, they are working more, but they're facing burnout. They're missing that opportunity to commute and having that downtime. And many teams are doing well and still producing, what they need to produce, but they're also concerned that they have less communication, which could have negative effects down the road. So we can't see these nuanced implications from telemetry data alone.
Okay, so we've looked at a need to examine a broader notion of beneficiary in Act 1 of the talk and a broader set of research approaches in Act 2. Now we're going to look at the types of knowledge that we tend to produce. And once again, we'll argue we can broaden in this area as well.
Right. So to look at the different kind of contributions that we can create, we turn to looking at the different kinds of sciences that we can do. And in particular, we focus on the explanatory sciences and the design sciences. And so, as Neil said, we try to categorize the contributions from our papers. And we actually try to simplify that in terms of two broad categories. The first one is in terms of descriptive theories or predictive theories. We tend to use the term descriptive theories to refer to both. And these are the kinds of contributions from the explanatory sciences, where we produce these insights about understanding the phenomena we need to understand and being able to predict what will happen if we make changes. The second category that we use relates to the solutions and the interventions that we produce in our research, the study of solutions or prescriptions to address a particular problem. This type of research is often referred to as design science, where our contribution is knowledge about the design of an intervention or tool. So design science can be conceptualized in terms of a problem-solution pair, where we aim to gain an understanding of a problem, and then we design a solution to address that problem. And our empirical work can occur in three processes. One, in understanding more about the problem itself, so studying the problem, say in the field. In the second, in terms of evaluating the solution, so independent from a real problem instance, we apply the solution we create to potentially some data or a simulation of the data. And then finally, in the third way, by applying the solution to a concrete problem instance. Now, we don't claim, of course, that a single paper should do all of the steps in this design science process. And in fact, most of our papers will only address one of these three aspects and should do it well. So let's look at one of the upcoming sessions at SANER. I think it's coming up in 2 days on recommendation and summarization. And let's look at two of these papers and relate these two papers to that design science approach. So the first paper that we look at is an ERA paper, and it's about human-centric issues in e-health, app development and usage, a preliminary assessment. And from our understanding of the abstract, we believe that this paper is more about understanding this problem that is faced in e-health app development. So it addresses this part of the design science cycle. And of course, for a solution, that is left for future work, with some ideas for future work to be validated. That is the contribution from this paper. The second paper that we look at is the one that Neil already talked about TechTube, summarizing relevant parts from technical videos. For this paper, they rely on related work that shows that developers want to look at these technical videos, but they're too long and they won't watch them. And so using that as their assumption about the problem instance, they come with the tool that extracts the relevant parts in the technical videos. Their first approach is to evaluate that with existing videos, a data research strategy. And then secondly, they also do a lab study where they summarize, where they take their tool and they apply it and see how developers experience it in terms of usability and usefulness.
We can broadly characterize our contributions as either sort of solution-oriented, as Peggy mentioned, or problem-descriptive. The solution-oriented papers tend to focus on tools and data, or we might explore and describe the nature of the software engineering problem. As you can see from this chart here, SANER this year is overwhelmingly focused on solution papers, with 26 papers that focus on a solution contribution, 11 papers where there was primarily a descriptive contribution, and 5 where we felt they did both a descriptive insight and generated some solution based on that insight. Now, again, we only had time to code based on the abstracts for these papers, so we may have mischaracterized your work. The link at the top there is a link to the Google Sheet where you can edit and update the coding that we assigned to your paper if we've mischaracterized it. So you might then say, well, so what? I like solutions, I like tools. But I think what we're arguing is if we don't focus on the design cycle sort of round trip process, we might find ourselves with what we call small telescope problems. So a small telescope problem is the idea that if you want to see some important but very hard to detect phenomenon like the light that comes from just after the Big Bang, for example, you're going to need a very, very big telescope, like the very large array that's pictured in the background here. For SANER, I think this means we risk doing research only on the things that we can point our existing small telescopes at. That is either a solution that's not motivated by a real problem, for example, or a description of a problem no one can solve or cares to solve. For example, if the current state of the art on a problem X is beaten by 3%, is the problem important? Does that 3% matter? And what was the cost of the solution? Okay, so we've looked at who benefits or should benefit. We've looked at the strategies we use to pursue the research and whether those strategies help test the benefits. And we've looked at the knowledge we produce with respect to design science. We're going to now turn to some possible solutions to these issues and end with 3 provocations for you to consider. The first solution we propose is to sort of aggressively expand our notion of a research artifact. Our current model of publishing is very much focused on the scientific paper as the primary contribution. We suggest a broader view of artifacts of research effort, one where the scientific contributions can be sort of mixed and matched. We might pull out from papers artifacts like the research method or protocol used, a data set, the tools that were used to produce the results. And doing this will greatly improve the ability for others and ourselves to build on the work. While we do have artifact tracks that award badges like the ones you see on the screen here, and the Rose Festival efforts, these are excellent, but not enough. They really reward making things available, but what we want to emphasize is not just that your paper can be reused, but that in fact it has been reused by somebody else. We're working on a tool, the Department of Reuse, which is sort of the working name anyway, that is, idea here is to track artifact reuse. So you have these digital object identifiers, DOIs, that we can use to build a graph of research activity, very loosely defined in that way. Several papers this year, for example, at SANER used the defects for Java dataset, which has been instrumental in spurring development in the automated program repair community. So you might expect to see some sort of graph representation linking back to the defects for J initial artifact.
Right. So in addition to this first solution, which is about having these reusable artifacts, the second solution that we want to put forward is to use and contribute to theories. So as well as mixing, so in terms of the descriptive papers that we have and that bring theories, this may seem obvious to use and to contribute to these theories. But we also have theories that emerge from our design science research. And these theories are often called theory fragments or technological rules, which seems like a complicated concept, but it isn't really. So a technological rule, you can think about it in terms of this simple rule down here: to achieve an effect in a given context, use a particular intervention. And an example of this is shown above it. So to reduce errors in open source projects, use continuous integration, which is a very broad technological rule. Typically our papers are more fine-grained than that. But what we can do is we can take these papers that are at finer levels of detail and our research findings and put them together to bring some larger insights that give us understanding about our interventions and our solutions. Note that technological rules could also debunk common myths, such as the usefulness of UML in industry, or that high code coverage is needed for reducing bugs over other methods. And our third solution that we put forward is to mix methods, to deploy mixed methods, at least at the community level, to be thinking about this and to be thinking about collaborations that do that. So in addition to achieving generalizability, realism, and control of human factors that we see from using these different methods, there are actually other benefits from using these methods. So data strategies are great because they scale and they're repeatable and they're unobtrusive in terms of the developers that we're trying to study, while field studies can give us very actionable insights on how the tools that we create are adopted, or even more importantly, how they are not adopted. And lab studies can allow us to control the human subject so that we can see what happens if we control certain aspects. So diversifying our methods, we think, is something that we can start and should start doing tomorrow. So we wanted to share with you also, so we told you that we applied this who, what, how framework to your papers at SANER, to the 42 papers. And we took what's in the spreadsheet and we composed it into a dashboard that you can explore. So you can now go and look at your papers according to the who, what, how. The link to this is on the top right corner, and there is a QR code if you want to go and explore it. Here's what it looks like in terms of its interactivity. Actually, let me just bring this down here a little bit so you can see the whole thing. So this is the dashboard, and we see that part of it shows the who, part of it shows the what, and these two over here show the how. Then we have some keywords, and we show the title, authors, and abstract, and you can search. So one of the trends that we saw this time was that there are quite a few papers on using AI and deep learning, not surprising because we have all of these new techniques. So you can search for neural, for example, and you will find when you search this word that we get, actually, it looks like we get 6 papers. The primary method is a data strategy. We get other keywords. We can look at the titles of the papers over here. And we see that one of the papers also uses a lab strategy as its second strategy. And we can filter selecting that. And we see that this paper is about a neural question answering system for basic questions about subroutines. So it's great that this paper also focuses on looking at the effect of their tool on the developers. So we mentioned, so we've given you 3 solutions, okay? We've given you this dashboard that you can use to explore the papers at SANER and get a way to get that overview. And we gave you these 3, these 3 solutions: reusable artifacts, building on theories, and using mixed methods. And now we're going to conclude with 3 provocations. Okay, so this is where you're supposed to disagree with us and discuss with us. We're trying to provoke you. Okay, so the first one is our research too narrow and silent? So in terms of it being too narrow, we're very much focused around doing research that fits in a paper, because these papers are what matter to us in terms of getting hired and getting promoted. And it's the way that we evaluate each other and value what we do. However, if we focus very much on these single papers, are we doing a good enough job of describing how we're addressing the bigger challenges? And at SANER, we're also focusing on using just data strategies for the most part, and that's fine. But maybe we should be slicing up our community into venues that look at solving particular problems. So more events that are, say, looking at security of issues or looking at software maintenance, which we do have, right? We have ICSME, but maybe we need to think about not siloing our community based on the types of methods that we use.
Our second provocation is about the criteria for good research. So Robert Felt in our recent keynote suggested that we should favor the truth of a research object over its novelty and its relevance. This is because it's been shown to be very, very difficult for reviewers to evaluate what exactly is novel, and the pursuit of novelty can itself lead to very bad research practices. The recent release of the SIGSOFT review standards might help to improve that focus on truth. I've got a little link at the bottom there. They allow reviewers to assess research methods using some checklist approach based on best practices in the field. On the other hand, the two of us feel like we read a lot of papers that merely report a very well-conducted study with some small increase on the state of the art and leave one wondering, so what? What is the point of this? After all, some very influential papers in our field, like Parnas's modularity work, had very little empirical truth that motivated them. So Peggy and I argue that we should instead focus on doing work that is new and potentially important, especially to address those wider challenges that we talked about.
And our third provocation is thinking about the pace at which we do research. Are we doing and approaching our research at a pace that is just too slow, especially given the fact that industry moves at a very, very rapid pace? Are we keeping up with the needs of the industry that we are ultimately trying to serve? And maybe we need to rethink the way that we do research and think about it more like agile software development. Perhaps even rethinking the size of our contribution, which contradicts a little bit what we said in provocation number 1, that we're being a little bit too small in terms of our units. But maybe if we had faster feedback on those smaller contributions and discussion about how those contributions fit in the broader landscape, we would do better in our research and we would have more of that big picture in mind. And also, if we get faster feedback, we would fail faster and we would be able to also work more closely with our stakeholders whose problems we aim to solve through our research. And so coming back to the vaccine that we talked about at the beginning, or that Neil introduced, Progress happened there because researchers used different methods and they shared their findings. Okay, I'm sure there was quite a bit of politics and competition along the way as well, but they built on each other's work. And because of that, we achieved something in the world that we had never achieved before in terms of vaccine development. So in software engineering, think what we could achieve if together we address some of the grand challenges in software engineering and built more on each other's work. And so we've repeated here for you these three provocations. Is our research too narrow and siloed? What matters more to you? Do you think it's truth, relevance, or novelty? And what can we do to get faster results and faster feedback? And with that, I'll conclude, or we will conclude, and we hope to get some questions and some discussion.
Wonderful, thanks so much. That was, here, I'll give the applause. It's hard for everyone to do that. Really fascinating talk, and there's already been a bunch of chatter on Discord. I'm assuming you guys weren't paying attention to that because you were busy talking, but I think you have definitely struck a chord with the audience. So people were very interested, and thank you for making your data available. People were very interested in that and looking at that. Let me use my chair's privilege to start off with a question, and then we'll throw the doors open. How well aligned is this with our incentives as researchers? You know, the people talk about the least publishable unit. We are incentivized to produce papers in particular outlets. We are incentivized to produce more papers because, you know, people will say that substance matters, but I think in many cases, maybe it's just my cynical view as an old guy, but people will, you know, say that, well, if you have 3 really amazing papers, you still won't get tenure. You've got to have, you know, 5, 10, 20, whatever the magic number is. So how do you, this is a very long question, how do you correlate or jibe what you're talking about with the incentives that are already in place for at least academic researchers?
Yeah, I'm going to let Neil jump in on that one because I think I think this is probably something that, you know, that he's thinking about, right, a bit lately.
Yeah, we had a slide on minimally publishable units as one of the problems. I think the purpose of the sort of artifacts solution would be that we need to, if we're going to move to that, like that sort of, we should reward the data set as much as anything else. I don't have a lot to say on how to make the dean accept the fact that you have 150 stars on GitHub. But for sure, in our engineering discipline, that's I think that's a really important thing that we should think about for promotion, for example. A colleague of mine, Martin Robillard, has built a tool, JetUML, for teaching people how to do UML diagrams quickly. But from talking to him, that doesn't really get looked at a whole lot in the promotion materials, right? It's more how many ICSI papers have you published, or sometimes it's not even ICSI papers, it's how many journal papers have you published. So I definitely think there's an incentive mismatch there. On the other hand, I think that, if we look at it from a sort of a networked view, like that slide I showed on the Department of Reuse, then maybe the sort of small publishable units are fine, and we should think a bit more broadly in terms of building on one another's work. So, you have a small sort of unit of work, but it's when we look at the entire thing that we can sort of put it all together and say, oh yeah, this is addressing the grand challenge. It's hard to, for example, if I'm writing a research proposal, I've got sort of lofty ambitions. And then when I look at the actual output, my publication record, it's, I have to sort of start piecing it together. But I think that story can be told.
I heard a keynote talk many years ago by Lotfi Zadeh, the inventor of fuzzy logic. And he said at the time that when he first started trying to publish, he was absolutely torn apart by reviewers. And that had he not already been a tenured full professor, there would have been no way that he could have done what he did and created this influential field of math and logic. So again, this is an incentives problem, and that's one of those true things. Certainly at the time when he invented it, the relevance of fuzzy logic was not understood. Mm-hmm. It was a mathematical set of theories that he had produced. And I think maybe those are the hardest ones in terms of incentives to argue for a new theory where the application maybe isn't as clear.
Well, and the vaccine is, at least my understanding of the story with I think the Pfizer vaccine, where the mRNA technique was for a long time just sort of dismissed, and no one really wanted to put a whole lot of attention into it. And now it's literally saving the world, right?
Reviled, not just dismissed.
Right. Yeah. And thank goodness, that was, that someone kept pursuing it, even though maybe they didn't get the rewards that other people were getting.
Yeah. Other questions from the crowd? I've been talking long enough.
Question.
Yes. Thank you.
Hi, my name is Razarta Krasniki, and I just finished my master's at University of Notre Dame, and I very much thank you for your insightful talk. I really learned something. So I have a question though. Since you've reviewed many papers at SANER, and I'm actually very new in the research community, but I'm very interested to know about how are the human values incorporated in these research papers, even though at SANER they're probably most technical, but are researchers emphasizing more focus on that? For example, when I say about human values, I mean there's always this public demand on motivating vendors to take preemptive measures and avoid violating human values. For example, Google has pledged not to use its AI tools for surveillance conflicting with human rights. So do you have any pointers or directions or insight on this aspect?
Yeah, maybe I'll take that one, Neil. So looking actually at the dashboard that we put together, let me just clear off here what I had selected. We also looked at the abstracts in terms of how many of the papers kind of mentioned human beneficiary in terms of aiming their research at supporting developers or stakeholders. And what we found was that let me see, both was 22. So 22 of the papers talked about both technical systems, but also talked about their researchers benefiting humans in some way. And just a couple focused, or from what we could see from the abstract, were focused on the human aspects. And then about 16 were solely focused on technical. In terms of the human values, let's search and see if anybody actually used that term in their paper or in their abstract. I don't think so. Yeah, so nobody actually used that term, but we can search for, say, developer. And I think we're going to find around 20 odd of the papers do specifically mention at least the developer. But in terms of, the end user and so on, I don't think, or in terms of human values and ethical issues, that isn't a big topic. Maybe let's search for ethics and see if that comes up. But you can explore and see if these topics are kind of emergent in this community. And if they're not, well, maybe they don't belong here. That's one question. That's one part of our provocation. Maybe that's somewhere else. That should happen, in the conference, next week. That's happening somewhere else on Zoom. But that's something for us to think about. Who should be addressing these issues, and which venues should it be happening in, and how should we go about doing it? A great question, and thank you for, as a new master's student, thank you for stepping up and asking that question. It's not always easy to do in a Zoom setting. Thank you.
Thank you.
Good luck with your research. And I hope you look at human values.
The only follow-up I'd have is there's some, I think it's John Whittle's done a paper recently on human values that you can check out. And if you look at the NeurIPS conference this year, they institute a sort of ethical statement about your research, quite controversial. But I think a very interesting initiative to say, what what are the implications of the research you're doing? Something that maybe we could think about as well.
Thank you very much, Neil.
Yeah, John Whittle's paper is really good. And Rashina Hoda is also leading research in that area as well.
We have a few questions on Discord, so let me read the first one from Felipe Pinto. The notion of agile in research is amazing, but how to fail fast in research when there's only one period per year to submit the paper? And a follow-up question, conferences expect paper-ready submissions. How can we incrementally evolve a paper in the context of a submission?
Neil, do you want to take that, or do you want me to jump in? I can jump in if you want.
Well, I guess, I think first of all, I think there's a move afoot to try and change that one period per year idea. So I think Laurie Williams is starting to have discussions about synchronizing the big conferences and making it easier to sort of move papers between those, and other communities like DLDB does something similar. So I think it's not just us saying this. So I think people are getting that message, at least for research papers. As far as sort of, here's my data set. I think we do have, data track at MSR, for example. We have early results. And I think there's some journals that are starting to look more at, for example, I'm working on a registered reports initiative with a couple of different conferences. And the idea there is that you submit the protocol to begin, and you haven't even collected data yet. And, the protocol is basically confirmed. Someone reviews that it's going to lead to some, has some interesting questions about it, and it's, well put together and whatnot. Then you go off and do the study, and your study gets published regardless of what you find there. So registered reports is one approach we could use for that.
Yeah, I think the registered reports initiative is amazing, and could really shift our community, have a really big impact on our community. One thing though, I don't know how we're going to manage is this whole idea of double blind review. If you have these early papers and you have, these registered reports. So we need to think about this. It's a complex system, right? It's a complex human problem. How do we think about all of these needs and sort of, fail fast, but also keep that, the biases out of our review system. There's also a proverb, be careful what you wish for. So I'm going to be PC chair for ICSI 2024, and that's the year they're going to introduce the double submission deadline. So we'll see how that goes, and I hope that people in the community will actually help. Because we're going to make a mistake. There's going to be things that aren't going to go smoothly, but at the same time, I think if you don't try, if you don't push what you're doing, you never make improvements, which is a software thing, right? If you don't push it far enough, it'll never break, and you're not pushing the edges. So yeah, putting your papers on archive again is another thing that we're starting to see. It's an emergent thing that people are doing, but again, it's this double blind review point that comes, and it's a very ad hoc process how we give and get feedback on our archive papers. But thanks for the question. That was a great question.
Tangentially related question. Let me just pick another one off Discord from Melo Canada. Does the emphasis on empirical validation drive us away from the great ideas paper? You mentioned Parnas's work on modularity. This is a great counterexample. Would that get published in the current climate?
I'm going to hand that one to Neil.
Yeah, in some ways it was, the early ICSI conferences, when I look at them, I feel like there were a lot of great idea papers. And for sure, the folks who started the Empirical Software Engineering Conference and Journal were somewhat responding to that and saying, these are wonderful ideas, and we have no idea if, this actually works. Test-driven development was one that I was looking at as well. And I think there's, so no, I don't think it would be published as a technical track paper at ICSI. I could see it maybe as a keynote, and even the near track, the new ideas or the emerging research achievements, early research achievements track that I co-chaired this year. We also don't see a lot, at least in my opinion, of course, that we don't see a lot of, hey, here's a really cool idea. The one thing I guess I'd say with Parnas, for example, is, this is a practitioner essentially who was working with very, very large software systems and had a ton of practical experience to convey. So I guess one of the things that would be nicer is to have people like Kent Beck or Mary Poppendiek, or the people in the patterns community like Rebecca Werfsbrock come back into the fold. I think we've kind of diverged, and in the early ICSEs and the early pattern conferences, there was this much tighter synthesis with some of the thought leaders in the practical practitioner community.
Yeah, really good question and good answer, Neil, to that. I think what we could be seeing a little bit is this pendulum swing, from having not enough rigor to having perhaps maybe too much being required, and maybe we'll end up going the other way, if we sort of make a shift in our community. This is a very topical point right now, and Neil mentioned the ACM SIGSOFT reviewing standards, which we have both contributed to, by the way. So we are a fan of the effort, and we are, supportive of looking at these reviewing standards. At the same time, we're both concerned about how they could be used. Could they, will we have kind of irrelevant and not very interesting papers that are very rigorous being accepted, and at the same time some of these great kind of pieces that maybe aren't quite as rigorous being rejected? And what do we want from our research? Do we want to be 10 steps behind industry, 1 step behind, or 2 steps ahead? And so these are sort of things that we need to think about and address as we go forward.
Yeah, I think it's arguable that many of the most important advances in software engineering in the last couple of decades actually came out of industry, not academia. And shame on us for not inventing, Agile or DevOps or whatever the big thing was that we've now glommed onto but didn't lead. Another question from Discord from Zach Coker. I've heard of people saying that researchers should focus on the risky ideas that are 5 to 10 years out. Do you have any comment on that? And as a related question, do you think researchers need to try to plan their research trajectory better in some way?
I mean, I guess I'm untenured as yet, and so I'm fairly early in my career, and I don't know. I feel in Canada, for example, we're asked to plan a 5-year research program as part of our basic research funding. So that exercise is sort of forced on you every 5 years anyway, and it's not forced in a way that I don't like. I think it's an excellent exercise. But then, I have a lot of master's students, one who's here today, Rohit. Hi, Rohit. And they're here for, 18, 20 months, and they do courses for a lot of that. So it's really about a year of a research effort. So I have to also plan for, what's Rohit going to work on, and how does that fit into the 5-year plan? So I do think that you should have that goal in mind. And that's certainly what I sort of envision for myself. But I find it's difficult sometimes to make sure that each thing that we're working on is sort of marching towards that particular objective. But I think that's very individual. I think there's some people who just love taking problems that industry has right now and trying to help them. And there's some people who are off trying to prove P equals NP or whatever. And that's, a much, much larger vision in my view. But maybe Peggy, as a more senior academic, has a different view on that.
Yeah, I think you summed it up well, that you have to ask yourself what you value and what you're going to benefit from it in terms of your individual approach. I mean, personally, I've always enjoyed working with industry and working on things that I can see could solve problems probably in a shorter time frame. However, some of my earlier research took 10 years before it reached industry, even though I thought I was solving a problem 1 or 2 years out. And related to that, I mean, there are, to sort of put a counterpoint, there are examples of some really amazing research coming out that does affect industry, and that is being adopted by industry. Mark Harmon actually is giving a keynote in 2 days, and his automated program repair work in SAPFix is a great example of many years of great research by him and many others that then became adopted, at Facebook. So it's not that all of our work is not having an impact. I think a lot of it is, and sometimes it takes a long time. But I do think it's worthwhile I do think it's worthwhile thinking about, okay, what am I really doing? And, you know, and I can use my own examples where I've worked on things. I can be a bit geeky with data, and I can be a bit geeky with the tools that I'm creating, and I'll get sort of heads down and I'll work on this thing. And then I'm like, wait a minute, what does this really matter? You know, what is this really going to change? And so I think it's a good exercise to sort of step back and question each other a little bit about, you know, relevance. While at the same time keeping some novelty, because it is the novelty. You know, we are the ones that can do that, can drive that forward. So it's a balance, and there has to be, I think, space in our community and in our venues for all of those things, for rigor, for relevance, and for novelty, and not to make sure that we cut, you know, the others out because of it, or we ignore the importance of the other aspects. That's a great question.
So there's a follow-on question, very related actually to what you just said, but I'll read it. So it's from Diego Costa. How to prevent the focus on relevance plus novelty to yield mostly sci-fi papers that never end up being used in practice, right? Kind of related to what you're just asking. What actions, he goes on to write, what actions can we do to foment a community with a healthy balance between rigor, empirical validation, and relevance novelty? And then he says, not expecting a full answer or solution, just wanted your take on this.
Yeah, Neil, do you want to jump in? Do you have a thought? Or
I mean, I guess the sort of typical approach is, you know, research track papers and the new ideas track papers. And I can't remember who it was that said this, but, you know, if we have the new ideas track and we have the industry track, you know, what's the technical track doing? And so I guess what, you know, I think that works okay. The registered report thing, again, the thing that when we ran that initiative, we got this really cool. So one thing is, hey, I want to get this paper published. But the other thing you get from the sort of phase one of a registered report is you get feedback on your research plan and your research idea. And, you know, nothing breaks my heart more than as a reviewer to see some, you know, usually a PhD student or something who's worked for a year on a study and there's just some flaw or you know, there wasn't very interesting or the idea wasn't terribly novel. So my view would be you want to, you know, like we said in that third provocation, I would like to get fast feedback and fail fast on those ideas so that, you know, we can say, I don't think this is going to be used in practice because you've gone out and you've asked somebody in your local sort of industry scene, how is this going to help you? If it is it going to help you? So I think that, you know, software research as a sort of CI process is a really interesting idea that we get the ideas out and share the idea. There's tons of ideas, right? That's not, I've never found that to be a challenge. Validating the ideas and you know driving the tool forward that implements the idea, that's where the hard work lies. So getting fast feedback, I think, is really important.
yeah, and it's a great question, Diego. And I might actually, I won't put you on the spot for it, but I might ask you, do you have an example of one of these sci-fi papers that you're talking about? Because if you do, I want to read it. I'm intrigued. You know, I don't think we have enough of these kind of things happening. I think the near track often turns into an era track, you know, an early results track, then a new ideas track. And in part, it's because we're trained as reviewers to reject things that we don't have evidence for. But I did have a thought and it's gone out of my head. Oh, yes. The other thing that we could perhaps think about borrowing from the software industry is this notion of hackathons. Right. So in companies, they will often play with very novel and kind of out there ideas in hackathons. And then there's research actually that's studying how innovations from hackathons then, you know, make it into the company and become, you know, sort of the value from the company down the road. And maybe that's something, I mean, we're supposed to do that in our workshops, I think, in our community. But I think often our workshops become sort of early versions of our conferences. And there isn't enough of this. Let's just be out there. Let's, you know, there are no bad ideas. Let's just, they're all good. Let's just explore all of them and, you know, bring in some of those sci-fi ideas that you're talking about. But please do share with me if you have some examples of those kind of papers. I'm going to read them. That's for sure.
Do you have other questions from the audience? Somebody can unmute themselves if they'd like to ask a question in the old-fashioned way.
Rick, I have a question.
Go for it.
Hi, Peggy. Hi, Neil. My name is Gias. I think
Yes.
Peggy, we talked before. So I'm an assistant professor at University of Calgary, and I'm kind of fanatic with user study. I think Peggy knows that as well. I did in 7 user studies of my tool in my PhD, and one of the papers that you highlighted in this keynote speech. And by the way, great talk, great presentation. And the paper, one of the 2 papers that you highlighted was co-authored by me, and all credits go to my co-authors, not me.
Oh,
So with that, my question, I mean, given that, I mean, I have done a lot of user studies and I have built a lot of tools, and and I have tried to publish that, and being on the receiving end, both on the rewarding side as well as on the other side, my insight would be that, I mean, it's great to have all of those things because we need all of those evaluation. But at the same time, if we expect that we want to have all of those things packed into one paper, that is often unrealistic. And I found that firsthand in many of my papers, which got rejected. It got published after a while, but I mean, many of the times the information was you're trying to do so many things in 10 page, and we don't get enough information of because you're trying to do so many things in one paper, and we don't get enough information of anything over there. And why don't you break it down into multiple papers? And if I take that into account, if I take that feedback into account, and if I hadn't had followed that in the papers that you highlighted today, that paper may not have been highlighted by you, because you could have said that this paper is not using data, is using data, or this paper is just using responded. You know what I mean? So
yeah.
so in our current practice, I believe that, I mean, not only that we have to change our perception, as well as at the same time we have to change how we are reviewing the paper. And we know that we are doing some great work with the empirical study guidelines and everything, but at the same time probably we also need a kind of paradigm shift in the way how we are thinking of conference papers and how we can evaluate them. And it's great that, Peggy, you are being the PC chair of ICSI 2024, and that's great for that.
Yeah,
So that's my
don't.
2 cents over there.
That is so, there's so many points. I hope it's okay, Neil, if I jump in this one, because it's just struck a passion of mine here. So I won't try to bring up that design science slide, but you remember that slide with the problem and the solution, and then the empirical work happens at the 3 points. Part of what, and I did that together with colleagues at Lund University, part of the reason that we did that was to try to point out that when we're evaluating a paper, that we only really need to have one of those contributions, and to take into account that this paper provides that contribution. I probably didn't describe that very well in the talk today, but if you can present your work through that lens, you can say, look, we are doing this piece. Somebody else has done this other piece, and somebody else, or we, will do that other piece in the future. Because too often I've sat on program committees where there's been a great idea for a tool, and they have validated it maybe in a simulation, maybe using previously collected data. So they show that it works, you know, they show that there's a need, and they don't then take the next step and evaluate, they don't apply it to the problem. But their paper gives insights on the problem, and it gives a solution. And it's like, this is enough to be accepted. This is what this contribution is. And so I think if we sort of have that in our head, you know, what our contribution is in the bigger landscape, then we'll do a better job of getting those papers accepted. You're right. We wouldn't have probably showed your paper if you hadn't used mixed methods. And so you caught us out there. But we were using that to kind of show a point. But really, our argument isn't that you need to use mixed methods at a paper level. It's really that mixed methods, we should be thinking of that more at the community level, right? And putting that together, or in a research program that's, say, over 5 years, and you put those different things together. What was the other point that you raised? Actually, a lot of points in there. Michaela Lanza talks a lot about, and he was, you know, he pushed back a lot on our community for sort of not accepting the good ideas of these tools, and say, you know, getting good visualization tools rejected because they didn't have the, you know, obligatory solution. And he claims that we're doing boring stuff, right, as a result. So I think that this conversation is really important. We do need that balance. You know, this is my contribution. Here it is. You know, it is the design, and the design is grounded in the requirements from the understanding that we did of the problem. To me, that's enough for a paper if it's articulated. but often it's not articulated, and then that's another issue. So sorry, I could go on for half an hour on this.
I know you're both very passionate about this, but thank you,
Yeah.
thank you for your response.
Yeah,
Thanks,
thanks for the
Jess.
question.
Thank you. Okay, well, thank you, both of you, for a really fascinating and engaging talk. I still have a list of questions that I'd like to ask, and I'm sure that's true of most of the people in the audience. So that's the sign of a good talk. You leave us wanting more. So thanks so much. Hope you can stick around for other parts of the conference, so show up for Social SANER. And unfortunately, our time has come to an end. I need to turn the reins over to Liam McCower, who will be chairing the software quality session. But thank you so much for your talk and your contributions.
Thank you, everybody. Thanks, Rick.